This is Mr. Ashton going through the Mathematics Unit 1 Non-Calculator Higher Tier paper from November 2019. The first sort of 9 or so questions, I think it was, have already been completed in the intermediate tier. So I'm going to jump straight into where higher tier continued. So if you want to look at the first 9 questions, have a look at the link below and that will take you to the intermediate tier and it will be the last 9 questions on there. Okay, so second page, your formula sheet. So you've got lots of formulas on here. Some of these you may use, some of them you probably won't. Let me just make sure the focus is on there better because I can't see the text coming through that clearly. That's looking a bit better, there we go. For instance, I wouldn't have thought we'd be using this or this in paper 1, definitely, okay? So, question 10. We can see a cone and we can see a hemisphere. So straight away we're going to be looking at these two formula here. Okay, I'll be taking either the volume or the surface area formula from there. Okay, so we're told that in this question we'll be assessing the quality of our organisation, communication, accuracy. That's only the 2 marks there. 7 is for the maths. Okay, so make sure you've got your head in the game about the maths, and then we'll worry about getting those OCW ones afterwards. But top tips: make sure you're putting in units throughout. Make sure any sort of thinking that you're doing is also being shared with someone who'll be marking your work, okay? So, we're told the diagrams below show a solid cone and a solid hemisphere. The cone has these measurements here that are all drawn in, the sphere has this measurement here all put in. It then says the two solids have, which of the two solids has the greater curved surface area? Curved bold. So the formula we're looking at is the surface area of the sphere, so that one there, but that's a sphere, we've got a hemisphere, so we'll have to halve that. And the curved surface area of the cone, which is pi RL. Now when we're looking at what we want here of the cone, we want R and L, we're not interested in the height. So if I actually come over here and start looking at what we've got, we're given the height. So that means we need to work out what this length here is, what they're calling L. Now I can see a right angled triangle there, okay? So I'm going to start by writing out curved surface area, cone, equals pi RL, and then I might just put in brackets formula sheet, and then I'm going to say to find L. Well, to find L, I've got a right angle triangle and I have 2 sides and I want to find a third side. I'm going to use Pythagoras' theorem. Okay, so Pythagoras' theorem is that the smaller 2 sides, 9 squared plus 12 squared, must equal the hypotenuse, the longest side, squared. So that would equal L squared. So I'm going to be expected to be able to do that in my head. Okay, 9 squared is 81, plus 144 equals L squared. Okay, 81 and 144, if unsure, you can still use all this to either side if you're working. 1 add 4 is 5, 4 add 8 is 12, carry the 1, 1 add 1 is 2. So we've got 225 is equal to L squared. So square rooting that would be what L is. So you're expected to know your square numbers up until this number. Now, most people know up to 144, which is 12 squared, but if I just write in the ones before it, 10 squared, 11 squared, 12 squared. If you notice the pattern here, add 21, add 23. The next one, if you're really stuck, is add 25, so that's 169. Then add 27. Again, this is only if you're stuck and you don't know them. Add 29, okay? 225. So that's 12 squared, 13 squared, 14 squared, 15 squared. So L is equal to 15 centimetres. Therefore, the curved surface area is going to be, so I'll say curved surface area is equal to pi times by the radius of 9 times by the length of 15. So the curved surface area of that would be, well, 10 times 9 would be 150, so come back 1 lot of 15, 135 pi centimetres squared. Now I've used quite a bit of that space already, but I felt it was important to explain what's going on. I haven't got any more space, so I should have maybe just been a little bit more careful. I could go obviously right to the very back of this paper and take on the additional paper, but I like to have all the working here on this page. So I'm then going to say curved surface area, the surface area of surface area hemisphere. Bear in mind we've got a sphere, which is 4 pi r squared. I would then divide that by 2, so that's going to be 2 pi r squared. So then to go and work out the surface area of the hemisphere, I'm going to say and hemisphere curved surface area would be equal to 2 pi times by the radius 8 squared. 8 squared is 64. 64 times by 2 is 128. So I'm going to say 128 pi centimetres squared. So which one has the greater? It's the cone. 135 is obviously bigger than 128. So I'm going to say, so the cone has the biggest surface area. Okay, just making sure that conclusion is obvious there, okay? Now, in order to get these OCW marks here, make sure you've used units throughout. I have, look, centimetres there for the length, centimetres squared, centimetres squared. Okay, I've made my conclusion. What I might do is explain what I'm doing here and just saying recalling square numbers. Just explain what you're doing in your steps if you haven't written anything in. Square numbers. I've already said that I'm using Pythagoras' theorem to work that out. And then, you know, I'm just subbing in the numbers here. So I could just go and say there's sub in the appropriate values to go there. Okay. And then fine, I've made my choice. Okay, over the page to question 11. Okay, so it says the illuminance of light I from a lamp depends on the distance d from the lamp. The unit used to measure the illuminance of light is lux. It is known that I is inversely proportional to the square of d. So this is where you want to go and make a statement, okay? I is inversely proportional. Now, you can get away without writing this one, but I'm going to write it properly. I is proportional, but inversely, so that's my proportionality sign, to 1 over the square of d. That means d squared. Okay, now your proportionality sign, this thing here, this means you will change it to equals k. All right, so all I'm going to do in the next line is change that to equals k, and k times by 1 would just be k. So I get to I equals k over d squared. Now, it'd be absolutely fine to go straight to that if you prefer, okay? But I am just sort of writing in the full sort of like work of how I start to generate that. We're then told that Keres measures the illuminance I to be 5 lux when the distance is 2. We'll go and sub those into then. You'll find out what the value of k is. So I is 5, the illuminance is 5, over d2 squared. So 5 is going to equal to k over 4. So what divided by 4 is 5, or times both sides by 4, and we get 20 is equal to k. What you need to do now is come back to this statement here, and now we know what the value of k is, we're going to sub that back in. So that value there of k is going to change to 20. So I'm going to say I equals 20 over d squared. Okay, it then says what is the illuminance of the light at a distance of 0.5 meters. Okay, so I'm now going to say I equals 20 over 0.5 squared. 0.5 squared is 1/4, 0.25, and if I divide by 1/4, it's like times in by 4. 20 times by 4 is 80, so my answer is 80 lux. Okay. Over the page on 16. Page 16, question 12, sorry. The points A, B, C and D lie on the circumference of a circle. EDC is a tangent to the circle at D. BAC is X, they've popped that in for me, and CDE is 2X, where X is measured in degrees. Then it says find the angle BCD in terms of X, express your answer in simplest form. Well, before we do that, I'm going to go and try and put in any angle that I notice here. And the first thing that I'm noticing is two things. I have got 1, 2, 3 vertices there for that triangle on the circle, which means it's what we call a cyclic triangle. But also you see here I've got a 4th vertex there to get a cyclic quadrilateral. So those two things are telling me two theorems. Where we've got the cyclic triangle, we have something called the alternate segment theorem. So this angle here will be equal to what the angle at the top is here. You would assume, and you might assume wrongly from parallel lines, say, oh yeah, Z angles. That's not true when we're talking alternate segment theorem. It's actually the opposite way round. So it's this angle here that is 2x, okay? So I'm just going to point to that and just say why that is. Alternate segment theorem. Okay? So, find the answer of BCD in the terms of x. You must give a reason. You must give a reason for each step of your working. Well, I'm doing that by then. There's nothing wrong with writing it on the diagram, putting it in there, but I might put it in here for safety as well. Okay. Now, the other thing that I noticed then was that I have this thing called a cyclic quadrilateral. All four corners of a four-sided shape lie on the circumference of a circle. Now that tells you something about this angle here and this angle here. And it's not that they're the same, it's that the opposites add to 180. Okay, so let's actually go and look to see what we've got. I don't think I can go and put in anything else easily now, apart from maybe this one here. I know that these two angles must add to 180, so if I do 180, take away all of this angle here, take away 3x, then I'd have what that angle is. And if we actually go and look to see what we're asked for, B to C to D, B to C to D is actually that angle there. That's the exact one we're looking for. So by just starting to put some angles in that I could spot has meant that I've actually answered this question. So I'm going to start off by saying C to A to D, CAD, C to A to D equals 2x because, and all you need to state is that alternate segment theorem. Okay, I'll just shorthand it here because I've already written it above. Alt-seg theorem. We can then say BCD, which is the one we're asked, is equal to 180, take away 3x even, take away 3x, because opposite angles in a, and this is the keyword here, cyclic quadrilateral. Some people call that cyclic quadrilateral, add to 180 degrees. So if we knew the angle B, if hypothetically we knew that was say 110, then this angle would have to be 70 because those two add to 180, okay? But I've just made those numbers up, okay? So it could be anything. Okay, over the page, we have got what is called an identity, okay? Now, we're told to show that this thing minus this thing is identical to that. They're basically telling us what the answer is. So initially, what I want us to do is completely ignore this bit here. And what I'm going to do is work with the left-hand side, okay? The LHS, the left-hand side. First thing I'm going to do is expand out the brackets here. And then I'm actually going to put brackets around that double brackets and then worry about that minus 3 after, okay? So I'm going to get 6x times by 8x, so that's 48x squared, plus 6x, minus 3, and then a big pair of brackets here, okay? I'm going to start to expand out these. Now, some people use the acronym FOIL, first out as in as last. I always just go and draw arrows. That 4x has to times both those, that plus 1 has to times both of those. 4x times by 4x is 16x squared, minus 4x, plus 4x, minus 1. Okay? The next thing I'm going to do is expand. I'm going to multiply each of those by minus 3. So I'm going to get 48x squared plus 6x, that's at the front. Minus 3 times by plus 16 would be minus 48x squared. Then I'm going to get, in fact, actually, I could save myself a line of working here. Minus 4 add 4 cancels out. Minus 3 times by minus 1 is plus 3. So I can then state here that the 48x squared cancel out, leaving me 6x plus 3. If you notice here, that's exactly what they told now. So ignore for now. Ignore for now. So I'm going to say, therefore, the left-hand side equals the right-hand side. And we're done, okay? All done and dusted. It then says hence. Now, if it says hence in bold, it means go back and use this working here, okay? Write down the value for which this equals 0. Well, we've just found out that all of that turns into that. That is the same thing, eventually. So I can just change that to just being 6x plus 3 equals 0. Okay, we'll now solve. So take 3 from both sides. 6x equals minus 3. Divide both sides by 6. Leaves us with x equals minus 3 over 6, which is technically the right answer, but I could get that down to minus a half, or I could get that to minus 0.5. All of those answers are correct and we'll get the mark. Over the page, on to question 18. Okay, a couple of different ways to solve this. I always go with the following method, okay? I find it's easiest. Leave a couple of lines, okay? Leave 2 of those lines. We're going to state that x equals this decimal here, but we're going to take it out of being recurring form, okay? So 7, 5, 7, 5, and one more for good luck, 3, okay? I just say dot, dot, dot. I keep on going 7, 5 forever. That's why we write the recurring dots. Now, because there are 2 dots there, I'm going to times by 1 with 2 zeros. So I'm going to times by 100. If I had 1 dot, I times by 10. If I had 3 dots, times by 1,000. Okay? So I'm going to times both sides by 100. So I'm going to get 100x. Then I'm going to times this by 100, which would shift all of those things along 2 places. So I'm going to get the decimal there in line. The 4 and the 7 will come across here. And then that 5 would come there. Then it goes 7, 5, 7, 5, 7, 5, dot, dot, dot. I'm now going to subtract the 2 equations from each other, lining up the equals and the decimal. 7, 5, 7, 5, 7, 5, 7, 5. They all cancel out. Then I've got 5 take away 4, which is 1. 7 take away nothing, 7, 4 take away nothing, 4. 100x take away x, careful, 99x. Some people say it's 100. Remember, we're doing algebra here. So 99x. And then to get it as a fraction, I need to divide both sides by 99. Now, one issue here. The issue is, it's a decimal in a fraction. Well, they're separate things, so I can't do that. Okay? So what some teachers do is they say, well, let's do 10x and 1000x and work out where they all cancel out to have no remainders at all. All I do is I say, well, if it's got a decimal, times that by 10 and times that by 10. So x is going to equal 471 over 990, and you're done. Okay. Next one here says, circle the correct answer to the following statement. You need to know what minus means. Okay. Minus, in terms of indices, means 1 over 16 to the 3/4. The 3/4, the denominator means we're going to find the 4th root of 16, and then we will cube it. The 4th root of 16, well, is it 1? 1 times 1 times 1 is 1, so it's not 1. Is it 2? 2 times 2 times 2, because it's the 4th root, we write it 4 times. 2, 4, 8, 16, it's that. Okay, so this would be 1 over 2 cubed, and then 2 cubed is 8, so my answer is 1/8. Over the page, okay, bit of search going on here. Also, know whether it's rational. Now, to be a rational number, we need to be able to write it as an integer divided by an integer, okay? E.g. a whole number divided by a whole number. So examples of rational numbers, so rational number examples would be 2/3, 7/5, 5, which could be written as 5 over 1 or just 5. All of those are what we call rational numbers, okay? Notice that 2/3 would be 0.666 recurring, okay? So you can have a recurring dot and still be rational. It just means an integer of an integer. Irrational examples, ones that you're expected to know. Square root of a non-square, so square root of 5, square root of 7, but not square root of 9 because that would be 3. Cube root of non-cubes, so cube root of 5, cube root of 7, cube root of any non-cube. Also a really good one, pi. Okay, the expression that I have in my head is never ending, but then also never repeating. Okay, that's what I have in my head as soon as I look at rational and irrational numbers. Okay, so that expression there, never ending, never repeating, would be for irrational. Okay, so pi is obviously a really famous never ending, never repeating number. Now, from here, what are we doing next? We need to start expanding out those brackets and looking for square numbers here. So your square numbers are going to be handy to have written down. So 1, 4, 9, 16 and so on, okay? Go as far as you can go. We've already gone in this video up to 225, so ideally you would know up to that, so it'd make your life a bit easier in some of these types of questions. And look at that, I've actually got enough lines to go exactly to 225. Okay, first thing, squared means times by itself. 2 plus root 5 squared means 2 plus root 5 times by itself. Okay, minus. Now that 500, I'm looking for the biggest square number that goes into 500. So 100 obviously goes into it. I don't think any of those will go into it. So I'm going to go with 100 times by 5. Easy way to spot it. Is there a square number that goes into 5? No. So it is the right answer. Divided by root 5 cubed means root 5 times by root 5 times by root 5. Okay, start working on this bit here. 2 times 2, so doing FOIL again, 4, plus 2 root 5, plus 2 root 5, plus root 5 times by root 5. Well, that'd be root 25, or root 5 squared, so the roots are going to cancel. It's just going to give me 5, which is just a normal number. Take away, what's the square root of 100? 10, times by root 5 would be 10 root 5, over Root 5 times root 5, root 25 or just 5, and then times that by 5. So we get 5 root 5 there. Okay, what we're going to do now is some collecting of like terms. 4 add 5, they're whole numbers, so that's become 9, plus 2 root 5 plus another 2 root 5 would be 4 root 5. Minus, well, I've got a root 5 on top and bottom, so divide top and bottom by root 5, and then 5 goes into 10 twice, which would then finally give me an answer of 7 plus 4 root 5. Okay, now root 5 I just chose as an example because it was that one there, but you can see it's given in the final answer. Now that number is rational, the 7, but as soon as I go and add an irrational number to it, the whole expression becomes irrational. Okay, that's irrational because we've got the square root of a non-square number still in it that we can't do anything with. Okay, over the page. The graph of 16 minus x squared has been drawn, blah, blah, blah. Use the trapezium rule with ordinates at 0, 1, 2, 3 and 4 to estimate the area of the shaded region above. So at those values, 0, the axis has already done it for us. Then I'm going to come and fire at 1, 2 and 3 and 4 is already done for us. We're going to have 4 areas here to go and work out. Okay. Now, what I would do is just go and write in what these values are. So let's check the scale. 0 to 5 in a jump of 10 little squares. Each square is worth 0.5. So this is 16. That's 15. That would be 12 and a half there, bang in the middle. So 1 down would be 12. That is 5, 6 and 7 there. And that's obviously 0 there, okay? Area of A is going to be a half of the parallel sides. That's going to be 16 and 15 then. And then that's going to be times by a height of 1. Okay, now obviously timesing anything by 1 just remains the same. So all we need to do is to find the average, find the middle of 16 and 15 there, which is 15.5. To work out B, I want to do a half of 15, what I ended in there, shared there. Okay, so I can straight away write 15, add 12 times by 1. So what's in the middle of 15 and 12? 13.5. For C, half of 12 plus 7 times by 1. What's in the middle of 12 and 7? Not sure, not easy to spot this time, so let's add them together. 12 add 7 is 19, half of 19 is 9.5. And then finally, D isn't strictly speaking a trapezium. You could still use the trapezium formula there and say, well, it's going to be 7 add 0 and work it out that way. Or you could just say it's base times height. So the base is 1, times by the height, which is 7, divide by 2, and that's because it's a triangle. So that's just 3.5 there, okay? Then to work out what the area is, we're just going to add all of those together. So 5 add 5 add 5 is 20. So 0 there, carry 2. Then we've got 5 add 3, which is 8. Add the 9, which is 17. Add that 3, which is 20. Add that 2, which is 22. Carry the 2 across here. 1 add 2 is 4. So my answer is 42.0, and I just say units squared for a fantastic answer there. Okay. It then just says, or part B says, the area can be estimated again using ordinates every half unit, namely x 0, x 0.5, and so on. It then says, without calculating the new area, tick one of the following boxes. Now, if I go and look at this, you can see that A is nearly trapezium. If I went and join them up, that's pretty close, isn't it? Okay. That's pretty close as well, okay? But there is a little bit of area that comes over it. If I chop that in half, like it's suggesting, and then did it, look how little area is left over this time rather than just connecting the two. It's even more accurate, okay? So the rule that you need to know is the more times you chop it into more pieces, the more accurate it's going to get, okay? So the area, now, it's not said is it more accurate or is it less accurate. When I do this current area, can you see that I'm underneath the graph every time? So if I cut it into more strips, I'm going to get more accurate. I'm going to get closer to that area, which I underestimated to begin with. So this area will be greater because it will be more like the real thing. Give a reason for your answer. Let's just say more strips is more accurate. Okay, so only 1 mark. That's all I need to put there. Okay. Okay, next question, number 17, nothing to do with the trapezium rule. It says simplify the following expression. Now, we've got a quadratic up on the top and we've got a hard quadratic at that because we've got a number in front of the x squared. So, what we are going to do to begin with, we are going to multiply together the first and the last term. We're going to multiply together 2 and plus 20. That gives me plus 40, and that sign is important, okay? They are going to add to whatever this term in the middle is. minus 13. And again, that symbol is very important, minus 13. Now, the fact that my numbers multiply to a positive, there's only two situations where that happens, a positive times a positive or a negative times a negative. It tells you that the signs must be the same. Well, because they add together to make minus 13, then they must both be minuses. So I know it's a pair of minus numbers. So I now need to pick a pair of numbers that times together to give 40. I'm going to go with the most obvious, 4 and 10. Minus 4 and minus 10 is minus 14. Not my pair then, because I'm supposed to get minus 13. Think of another pair. Okay. 40, what, minus 2 minus 20? That's minus 22. No, it's not them either. Okay. Another pair, 5 and 8. Minus 5 minus 8 is minus 13. Ding, that's my pair. Now, depending on how you've been taught this in school, you might do a slightly different method to me. But what I do is I drop just the squared from the front of each bracket. Okay, just the squared. Minus 5 goes in one bracket, minus 8 goes in the other bracket. Now, what you must do if you do this method is you must cancel down any brackets that have a common factor. So 2 and 5, no common factors. 2 and 8, yes, they have 2 goes into both. So to simplify that now, it would be 2x minus 5, that's untouched, and then 2x divided by 2 would be x, and then minus 8 divided by 2 would be minus 4. 2x times by x is 2x squared, minus 4 times minus 5 is plus 20. If those two work, I bet you the rest of it will as well. Now on the bottom, I need to see if there's anything I can factorise, and they're both even, so I can bring out 2 there as a factor. And then I'm going to get x minus 4 there, okay? Now you'll see on the top and bottom I have x minus 4 in both, so I can divide through by x minus 4 and they cancel out, leave me with 2x minus 5 divided by 2. Now, I do not say, oh look, that 2 cancels down and get x minus 5. That's it, that answer is done, that's finished. And the reason why is I could cancel that is you see they're touching, that means it's timesing, touching, timesing. If your numbers are timesing together, if they said 2x times by 5, then dividing by the 2 would be no problem at all. However, if they're adding and taking away, it doesn't work. So for instance, if you looked at saying 14 divided by 4, okay, we know that would cancel down to being 7 over 2. But if I change that to, let's say, 10 add 4 over 2 add 2, and say, oh look, the 2 goes into 10 5 times, and the 2 goes into that 4 2 times, then the answer is 7. Absolutely not. The answer to that is 7 over 2. We can't just cancel down like that, okay? So that's just me sort of just explaining that bit there. Okay, over the page, on to the very last question. Fantastic. We've got the following thing told to us. 16 balls are placed in a bag. 10 of the balls are green and 6 of them are yellow. 2 balls are selected at random and not replaced. Okay, I could have told you that was going to be the case because it's the last question, therefore it's going to be the very hardest type. Benjamin states the probability of selecting 2 balls of the same colour is equal to the probability of selecting 2 balls of different colours. Is he correct? Show working to justify your answer. The first thing we're going to do then is generate some probability trees, okay? So I'm going to start off just by drawing here and here, there. That's my first pick, and my second pick there and there. Now there's only 2 colours here, so I can just literally just say green and yellow, green and yellow, green and yellow, okay? The chance of me getting a green ball in the first pick is 10 out of 16. Yellow is 6 out of 16. Now because they're not replaced and I've just selected a green, I've only got 9 out of 15. The yellows, there's still 6 of them, they've not been chosen. Okay? Here though, the other way round's happened. I picked a yellow, so now there's only a 5 in 15 chance, and here there would be a 10 in 15 chance. Okay? Now to work out the probability of getting green then green, I would multiply these 2 fractions together. So 10 over 16 times by 9 over 15. I'm just going to write down all of these straight away and I'll worry about answering them in a second. Now you could cancel some of these fractions down, but you're not required to. It won't get you any extra marks and you could go wrong and you could lose marks. So I tend to just leave them as they are. 10 times by 9 is 90. 16 times by 15. If you're unsure, go and do something like splitting them up. 10 and 5 times by 10 and 6 and work it out that way. So we've got 100 and 50 and 60 and 30. That comes to 190, 240. So 240 there. And you can leave it as that. You don't need to cancel that down. This would be 60 over 240. This would be 60 over 240. And then this would be 30 over 240. Now Benjamin has said that getting the same colour is the same as getting the different colours. So the same colours, green then green, is that one there, or yellow then yellow, so that one there. The different colours then are the other two answers. It's this one here and here. So if I go and look at adding together the two different ways I can achieve those, 90 over 240, add 30 over 240 is 120 over 240. 60 over 240 plus 60 over 240 is also 120 over 240. These are the same, so he's correct. So Ben is correct. Okay, that's everything done there. Thank you very much for watching. If you're interested in the stuff that I've already talked about and getting some face-to-face tutoring or some online tutoring for me, absolutely something that is now available moving forward from January 2023. Thank you for watching.